Hello everyone, welcome back. This video recap, we're going to talking about the 4 bits for adder. Okay, let's go to our website. Okay, our 4 bits for adder is based on a 1 bit for adder. If you don't know how to create a 1 bit for adder, please check the previous video recap. And okay, I assume you already finished the 1 bit for adder, so let's start from there. Okay, after you finish 1 bit for adder, and from the left window, hierarchy window, you can see right now the for adder includes a lot of components. Okay, I have already created 4 bits for adder entity file for you, so you just need edit. So right click and add source, and in this folder choose this one. So last time we add AND gate, OR gate, and XOR gate into the project. Right now, this time we should choose for adder 4 bits HDF file. Click OK and OK. So after you add it, so there's another file, 4 bits. Double click, you can open it. Okay, so right now, how to design the 4 bits for adder actually is based on the 1 bit for adder. So right now, the 1 bit for adder is the component of 4 bits for adder. So on the left side right now, so look at this symbol. This icon indicates which module is the top module. So right now actually we want to the 4 bits adder is the top module, and then we can use the 1 bit adder as the component. So let's change it. On the 4 bits for adder, right click and choose set as top module. And we confirm, yes. Okay, after you confirm, you see this top module icon is changing from the 1 bit for adder to 4 bit for adder. Okay, so that's the first step. And second step, we still have to declare our component. So this time we don't have to declare our AND gate, OR gate, or XOR gate, because that's all the components for 1 bit adder. But right now, we only need to declare the components for 1 bit adder. So the process is the same. So let me show you what this looks like. So for adder, so in the 4 bits adder, and we declare the component for 1 bit for adder here. So the same thing for the component for adder, and you can write the component and the component, and the ports you can copy and paste from 1 bit for adder file. Okay, after you declare this, okay, the same thing for the next step is do the instantiate here. So let me show you. Okay, so we also split our window. On the left side is our code. Okay, on the right side is the slice. So the four bits for adder, we have instantiate 1 bit for adder, 1, 2, 3, 4, and so from the declaration for this component, you can see. So this time the A and B is not 1 bit. Actually, A and B is 4 bits. Is 3 down to 0. A and B and S out. So each bit for A and B and S out goes into one bit for adder. So this is a 3 down to 0. So 0 bit of the A and B and S out, and the second bit 0 bit, 1 bit, 2 bit, and 3 bit. So there are 4 bits, and each bit goes into the specific 1 bit for adder. So that's how we instantiate. So that is first we instantiate the adder 0, 1, and 2, and 3. So the first is for adder 1 bit. So the type are same. Okay, and the first one, the CIN, here right now I gave you 0. Actually, you can declare here is 0, or you can give the CIN. So CIN right now is declared as the input port of the 4-bits adder. And then, so the A port of this 1-bit for adder comes from A0. So A is the input ports of the 4 bits for adder, and we use the parenthesis 0 to indicate that we just want to grab the 0 bit. Okay, and the same thing for B, and the output is S out 0 here. And the C out, okay, look at here. C out is this wired. Okay, so from the first 0 for adder, 1-bit for adder, it's connect to give it to the second bit for adders in CIN port. Okay, so I name it CIN_0. So definitely, if I name it this wired here, I will declare the signal at the beginning, at the top here. Okay, so so the same thing for the second one. The second adder, the CIN is the CIN_0. It comes from the previous component, from the previous one. And the A and B and S out this time is the index 1 bit. Okay, and C out is CIN_1. So it indicates this wire. Okay, the same thing for the next two. So I give it. So the last bit, the last for adder, the C out. Actually, the C out is the 1-bit for adder C out is the C out. This C out is the 4 bits for adder's C out. So that's the signal for this component. Okay, so bigger one. Okay, so that is how we design the 4 bits adder. Okay, so let me show you what this looks like. So if we change the code for this time on the hierarchy window, you can see. So right now, under the 4 bits for adder, we have 4 1-bit adders, and each one we have a lot of components for the gate. So that is a hierarchy way to design the 4-bit adder. So we double-click the synthesize to check the syntax. Okay, it's successfully. And then we have to create the test bench for the 4 bits adder. So the same thing on the entity, and right-click, click New Source, choose which DL test bench, and here we give the name. So this time we name it for foo adder 4 bits underscore TB. TB is short for test bench. Click Next. And for this time we have a lot of modules to choose to make sure you associate the source to full adder 4 bits. So we want to create a test bench based on the 4 bits adder. Click Next, Finish, and yes. I'm pretty sorry, so that shouldn't happen. And okay, so after you create the test bench, if this correctly, so it looks like this. Okay, so that's just to check the component for adder here, if it is so, which means it's correct. So also the same thing, I already deleted the clock part. So if you have the clock signals in the test bench, you should delete it or comment out. For details, you can check our previous video recap for 1-bit for adder. Okay, so for this test bench, I want you to test these values. Okay, so CIN for the 4 bits adder also have the truth table for the 8, and the AB, and we just change the value from the 1, 2, 3, 4, 5, 6, 7, 8, and so that is how to declare the test bench. So this time, since A and B are 4 bits, so we can give the multiple values for them. 4 bits, which means for unsigned number, the range is from 0 to 15. So we can choose. I just randomly choose the values here. You can change it, but you can just follow this values. And here we have two ways to give the values. Here, this way, I gave the x, begin with the x and the double quotation and the number 1. So this indicates this value is a hexadecimal number. And I give 1 to A. So the same thing I can give the binary code. Binary code, I have to give it 4 bits binary code. And the 1 is indicate 0, 0, 0, 1. So they are same. So if you like, you can use this way to indicate the hexadecimal number, or you can just directly use double quotation to indicate binary code. Okay, binary number. So you can choose either of them. Okay. Okay, and save it. Okay, so let's choose the 4-bit test bench and double-click a simulation behavioral model. And let me show you the results. Okay, if it's running correctly, it should be like this. Okay, and right now the default Redux is binary. So right now it's all the binary number. We can choose all of them and change the Redux to hexadecimal or unsigned. Let's choose unsigned decimal number. Okay, and here's the number. So what's the meaning for them? Okay, CIN A and B are our inputs. So for this time frame, we have 0 for CIN, and A is 0, B is 0, and add them together, so the output is 0. So that's true. So let's choose this. Okay, you can click here. So 0 for CIN, 7 plus 8, A plus B equals to 15. Yes, correct. And there's no cout, no carry. Okay, so since we use the 4-bit unsigned number, we can support 0 to 15. So that is why here. Okay, 7 plus 8 is 15, and we have CIN from the previous module. So 15 plus 1 is 16. So we have 1 cout, and the output is 0. So this is this is 1 0. It's not 10. Okay, it's because this 4 adder we support is a hexadecimal 4 adder. You can support 4 bits adder. So that's correct. And then this is the wave. Don't forget to have a screenshot and put it in your lab report, and also fill in the blank here and have this table. So for the lab 1, we have 2 parts. So 1 bit for adder, the wave, and this table, and 4 bits for adder, the wave, and the second table. So only 4 pictures. So put them in your lab report. If you like, you can give me the code, but it's not required. Okay. So that's it. That's 4 bits for adder. I hope you can follow this, and see you next time. Bye bye.